In this video, we're going to take a look at solving equations that contain rationals. And again, rationals are just algebraic fractions. So let's start off with a fairly easy example. 6 over 7x minus 3 over 2x equals 4/7. Now there's more than one way to do anything in math, so what I would recommend is this method, which I'm about to show you, versus what I see some people do is get a common denominator and combine the two fractions together first, these two fractions, by using a common denominator of 14x. Now, I'm not going to do it that way. What I suggest doing is multiplying the entire equation by the common denominator. Now, as mentioned, the common denominator is 14x. So what you do is multiply every single term by 14x. So I'm just going to stick a 14x in front of each term, and now I'll multiply. Well, going back to the first fraction, 7x cancels into 14x twice, 2x cancels into 14x 7 times, and on the right-hand side of the equation, 7 cancels into 14 twice. Now, by doing that, all the fractions are gone, and we just multiply to see what we remain with, and that is 12 minus 21 equals 2x times 4, which is 8x. Alright, at this point we just solved. 12 minus 21 is negative 9 equals 8x. Divide both sides by 8, and the answer is negative 9/8. Done. So that technique will work on a variety of rational equations. Let's take a look at one that's a little bit different. I'll scroll down here for a new page. Example number 2, x over x squared minus 9 equals 3 over x minus 3. Again, there are several different ways to approach this problem, but I'm going to go with the same technique I used on the last one, and that is find the common denominator. Well, the common denominator, in order to find that, first we'll factor the fraction on the left, which is x plus 3 and x minus 3. So we see that the common denominator is both of those factors. LCD equals x minus 3 times x plus 3. So I'm going to multiply both sides by that common denominator. So I'm going to put it next to each one. Now, what happens in these problems, it tends to be a lot of writing, but we won't be lazy. We'll just write it all out. X plus 3, x minus 3. So I'm multiplying both sides by the product of those two factors. And when I do that on the left, x plus 3, x minus 3 cancels completely. On the right, the x minus 3 cancels. So what are we left with? On the left-hand side, we just left with that solitary x. On the right-hand side, we're left with 3 times the quantity x plus 3, which I shall distribute and get 3x plus 9. And now I'm going to take the 9 to the left by subtraction and bring the x on the left over to the right by subtraction. So 3x minus that x gives me 2x. Divide both sides by 2, and x equals negative 9/2. And that is the solution. There's a little catch on these problems, which I'll show you on the next example or two, and that is when you examine the original problem, what I like to do is look at the denominators and think, what value of x would cause those denominators to equal 0? Well, in this case, if x equaled 3, the denominator would equal 0, or if x equaled negative 3. So when you think about that, if you get an answer that is 3 or negative 3, we're going to have to throw that out. Now, that didn't happen in this problem, but it's going to happen in a problem coming up soon. So if you get answers which cause the denominator to equal 0, we call those extraneous solutions, and they are not valid solutions, so we throw those out. Extraneous. Alright, let's take a look at another example. 1 over x squared minus 4 equals 3/4. This one is just a little bit different. Now again, it would be easier, actually a little bit, to do this a different way. But I want to be consistent. And that's the name of the game here, is if I can show you consistent methods to solve these problems, you can always rely on those. If you know a shortcut method, you may take it as long as you know what you're doing. In this problem, I would take the shortcut personally, but I want to be consistent on this video. So the first consistent step is to find the least common denominator. Well, the least common denominator, I'm going to factor the denominator on the left, x plus 2, x minus 2. So I can see the least common is all the different factors I see, which are 4, x plus 2, x minus 2. So I'm going to multiply both sides of that equation by that big old common denominator, 4x minus 2, x plus 2. I just saw I missed a plus sign on the right. Let me go back and fix that. Make sure we can see that as a plus sign. There we go. And on the right, multiplied by the common denominator also, 4x minus 2, x plus 2. Alright, now the fun begins. We get to cancel. So x plus 2, x minus 2 on the left cancels completely, leaving with only a 4 times 1. On the right hand side, the only thing that cancels is the 4 in the denominator with the 1 we just put in the numerator. So now we have 3 times the quantity x minus 2, x plus 2. Alright, now I'm going to multiply things together here. X plus 2, x minus 2, I know from the original problem is x squared minus 4. So distribute 3 times x squared minus 4 will give me 3x squared minus 12 on the right hand side equals 4. At this point I am going to bring the 12 from the right to the left by adding 12 to both sides, and I get 3x squared equals 16. And since we just have a single term that contains an x, I'm going to solve this by dividing both sides by 3. 16 thirds equals x squared, and taking the square root of both sides. So the square root of 16 thirds is plus and minus the square root of 16 thirds equals x. And we can clean that up a little bit by rationalization. The numerator, of course, is a perfect square, so we get plus and minus 4 over root 3, and then I'm going to rationalize by multiplying numerator and denominator by root 3 and get plus and minus 4 root 3 over 3 as our final answer, which is our x. Now again, if you look back at the original problem and think, what value of x would have caused the denominator to equal 0? It would have been a 2 or a negative 2. And since those did not appear in the solution, we don't have to worry about them. They are not extraneous roots in this particular problem. Alright, let's take a look at one more. Since this technique is the same one we're always going to use, so one more example should suffice. This one will make it really complicated. X over x minus 1 equals 1 over x plus 2 plus 3 over x squared plus x minus 2. Alright, let's go for the LCD. LCD, every different factor I see, well, that third denominator needs factors, so let me reverse FOIL that. X and x, and it's going to be a 2 and a 1, and since the middle term is positive, it'll be plus 2 and minus 1. Now at this point I say, well, those are all the different factors I see, so the LCD is x plus 2, x minus 1. Multiplying both sides of the original equation by that. Oh, I have to write it 3 times. Gonna get a hand cramp on this one. X plus 2, x minus 1. Write it again, not being lazy here. X plus 2, x minus 1. The reason I say to do that, use a little self-discipline, make yourself write those things. You are less likely to make errors if you do that. So cancel time. X minus 1 cancels on the left, leaving x times x plus 2 quantity. On the right, the first fraction, the x plus 2 cancels, leaving 1 times x minus 1. I'll just leave that 1 off, don't need it. And in the third fraction, since we factored x squared plus x minus 2 into those two factors are going to cancel completely, leaving with just plus 3. Okay, distributing on the the left, x squared plus 2x. I'm going to bring that x from the right over to the left, minus x, and then we're left with negative 1 plus 3, which is 2. Let me collect terms and do two things at once here. I'm going to add my x's together. 2x minus x is 1x, and bring my 2 over by subtraction equals 0. What we have is a quadratic equation which can be factored. So we factor it into x plus 2. Sounds familiar, doesn't it? X minus 1. And we know that that quadratic, we set each factor equal to 0. And get two solutions, x equals negative 2, x equals positive 1. So some students will make the mistake of feeling satisfied and saying, oh boy, I got the solution, I'm done. But wait, on these rational equations, word of caution again is look out for the extraneous. That's why I think about that mentally. I don't write things down, but I think about it before I start a problem. I'll take a look and say, oh, well, let's see. What values of x are going to make that undefined? In other words, a 0 in the denominator. Well, if x equals 1, that would be undefined, and if x equaled negative 2, that would be undefined. But that, oh my gosh, those are the solutions I got to this problem. So neither one of those solutions will work, which means the final solution to this equation is the empty set. No solution. So again, watch out for those extraneous solutions. They'll catch you off guard sometimes if you're not watching out for them. Well, those are 4 examples of rational equations using the same technique of finding the least common denominator and multiplying each term by that common denominator and then just solving the equation. So that'll sum up solving rational equations.